Good morning. Welcome to Viewpoint, your program of personalities, politicians, and perspectives. And as always, we have each of those all combined in one person this morning.
Yeah.
We're happy to have the gentleman back this morning. Well, we could have started out the old Walter Winchell thing, he wore his fedora hat. Good morning, Mr. and Mrs. America, and all the ships at sea.
Right.
Okay, kudos.
Yes, please.
I got a piece of mail the other day that disappointed me. Understandably. For years, you're aware of the fact that the young folks at the St. John's United Church of Christ have entertained veterans at Veterans Day. It's gone on for a number of years now, and they've done a great job. And, any veteran out there, or any veteran's family, it just occurred to me around this snap thing that just popped into my mind. Why don't you take an envelope and stick $5 in it and send it to the St. John's Church and tell them to do what they want to do with it as a charity. Unfortunately, the reason what prompted my conversation about this at all is COVID has taken over.
Oh,
and
so much.
Very reluctantly, they have decided to forego their annual recognition of the veterans. So, on behalf of every veteran that's ever been there, I'm just going to extend a warm thank you to St. John's United Church of Christ and their kids. And as I suggest, maybe somebody might put an extra $5 in an envelope and say, Bill said hello.
Yeah.
So thank you to St. John's United Church of Christ. Let's get serious now.
And we'll want to kind of watch, speaking of the coronavirus, kind of watch what the heck is happening now, because they're reassessing their number setup and system and gathering and so forth. And you never really know what you know.
Who's on first?
And what you don't know.
Well, they manipulate these numbers for whatever reason. And so, as you know, if you pick up the newspaper or listen to TV, you don't know whether the numbers are valid or not. So
No. Well, it's a matter of funding. It comes down to the almighty dollar.
Well, speaking of validity, we know one guy that'll give us the valid stuff on the weather, so go right ahead.
A real man.
Yes, he is.
Well, thank you.
Our friend Chris Miller. Chris, I think we've been having you come and chat with us, bless your heart, since we started.
Maybe it's because we're slow learners and we don't remember what you said.
Well, as the years go by, one does become a little slow. I tell you, I remember my sainted mother saying, "Oh, I miss my mind," and I know now where she was coming from. Chris is with the National Weather Service, and he knows what he's talking about. And you'd think that'd be easy. Just look out the window and say, well, I think it's raining. Well, it's not quite that simple, is it, Chris?
No, not at all.
In fact, just a few days ago, we had a mell of a hess, if you'll excuse me, down on the border of Texas and Louisiana.
Oh, boy.
That is something you don't see very often, thank you, God.
Yes, that hurricane was actually one of the top 5 strongest hurricanes to hit the Gulf Coast. That had, it strengthened just amazingly quickly. I couldn't believe how quick that thing strengthened because it started out as a tropical storm in the Gulf. There was all this concern about, it's going to weaken, it's going over Cuba and all these other areas, and then it's going to swing up and it's going to be a hurricane, but probably not too bad. And then it slowed down a little bit, and that we hate to see that, because when those things start slowing down like that, they have more time to gain strength.
Okay.
And it went from a tropical storm, which, to put the difference between a tropical storm and a hurricane, a tropical storm will give you winds kind of like one of our typical thunderstorms around here. 40 miles an hour, 35, 40 miles an hour, something like that. Very heavy rain. I mean, it's the rainfall is just tremendous from these storms. But when you get to a hurricane, that's when you start to get the wind gusts. You're up in the 75, 80 mile per hour range, and
that's
not just
pretty healthy.
Which makes the rain go vertical. I mean horizontal.
It's horizontal rain, yeah. And the difference there too is, it hits you for hours at that speed. Not just, when we get a thunderstorm here, we'll get a gust, and even that big storm they had in Iowa about 3 weeks ago.
Yes.
That was terrible. Iowa, northern Illinois, They're still recovering from. They will be for a while out there. Those poor guys. But I'll tell you, that one, it had gusts of 75 to 100 miles per hour, but for about a half an hour to 45 minutes.
That's a long time,
That
isn't
is a
it,
long
for
time
something
to
like
have
that?
wind that high. But to have this with a hurricane gusting to those speeds for hours is, you can't imagine the devastation.
No.
Then you had the residual of the standing waters
Oh, my
after
gosh.
those things.
Yes.
And of course, if you haven't had damage before, then you sure as heck will get damaged by the standing waters.
Absolutely.
Or
And-
rushing waters, too.
Yeah, the rushing waters, the standing water, the raining water, it's all you got water coming from every direction. And the thing about the Louisiana coast, too, and parts of Texas are this way, too, but Louisiana especially sits so low. I mean, there's communities, I think it was the community of Cameron, Louisiana. I mean, they are right off the Gulf. And they are just a few feet above sea level. And that water just came in and flooded the whole town. And whatever the wind didn't do, the water just covered everything.
Well,
So-
and even at that, they said that the surges weren't as bad as they were afraid they might be.
Yeah, in the populated areas, yeah, they were looking at surges getting up maybe as high as 20 feet high. You can't imagine,
my.
a two-story building. They did get up to about 15 feet high, but in the swamp areas where there weren't any communities or where people weren't living. I saw somebody from the Hurricane Center. They were tracking the storm, obviously, every minute, and they said there was just before it made landfall. And hurricanes do this. They're rotating, and because they're rotating, they kind of wobble a little bit, and then that'll cause them to change direction. It's kind of like when you're spinning a top, and it spins, and when it gets to spin down, it wobbles a little bit. Well, the hurricanes will do that too, and this thing wobbled just enough that it changed course a little bit. And when it did that, the high storm surge shifted to a different area that was not populated. So, I'll tell you, the good Lord was looking
Prayers
down for
were
him
answered
there. Oh,
there.
I'll tell you.
Well, for those of you who might not know, not everybody knows about our weather station out here. Or we may have somebody that don't like the weather and want to protest. And so you just call George Soros and he'll send you some signs of several hundred people, and you can go out there and protest. But let's tell them where there is. So, Chris, seriously,
Yeah.
we've been privileged to have you and your staff out there for a number of years now. Let's go back to the history of the when that weather station here east of town first started.
Well, I'll tell you, Bill, we started 25 years ago.
Think of that.
This was our 25th anniversary of beginning operations there is the end of September, the end of this month. We were another casualty of COVID. We were going to have a big celebration. We were going to have an open house and invite people from all over Central Illinois.
With fewer than 10 people.
Yeah. And I guess now we can do 50, but at any rate, it was 25 years ago. The planning on that got started in the late 80s with the National Weather Service as a whole saying, look, we need to do something with our radar systems. Most of the radar installations we had across the nation were built in the late 50s. They were and a lot of those were built from parts left over from World War II, actually.
Oh my.
Yeah, and so anyway, we upgraded the system in early to mid 70s, and put in a couple of newer radars. Springfield at the airport had one, and then we thought, we got to do something different because Doppler technology is becoming more affordable to be able to put them all across the country. So we had to put one somewhere in Central Illinois. We wanted to find out, where we're going to put these. Of course, there was a very loud group up in Peoria that wanted it up there at the airport. We already had an installation there. Mm-hmm. There were several groups that said we should put it in Springfield because we had an installation there, just put in a different radar. The university over in Champaign-Urbana was talking about having it over there. we decided as an agency, and after working with some of the folks on the county board at the time here in Logan County, that Lincoln would be the best place for it, for a number of reasons. The best reason we thought was because the best view you're going to get from Doppler radar is when it's roughly 30 or so miles, roughly, it's kind of a 20 to 50 mile nice buffer in there where you get the best data. That would cover Peoria, Springfield, Bloomington, Decatur, just about getting to Champaign. So the biggest areas of central Illinois. Plus, Logan County just welcomed the Weather Service with open arms and said, we've got some land out here at the airport that we get you a really good price on. And so they
Worked out well.
they worked out well, and probably, I don't want to say this is the most important thing, but it played a huge role, is that it was Bob Michael's congressional district.
Oh.
And, and back then, he was a pretty heavy hitter.
Oh,
Yes,
yes.
he was.
In the mid and late 80s when they were
Oh,
planning
yes.
all this. So, yeah, he was very insistent that it was going to be in his district, and that he could, help congressionally and whatnot, which he did. Anyway, the building actually started construction in late 1993. They broke ground, and by early 95, we were moving stuff in. We were starting to do our weather balloon launches. February of 95, we started doing that. I was just, at the time, I had only been at the Peoria Weather Office for about 7 years. So we were doing balloon launches in Peoria, and all that got shut down, moved here to Lincoln, and then all the forecasters and many of them, a lot of us are still there yet. We've been there for the whole 25 years.
Since Hector was a pup, huh?
Pretty much.
We ought to identify the balloon launch thing. Now, that's not Seth Goodman going up in his Mr. Lincoln balloon.
Right.
But seriously, and it is a serious matter.
Yeah.
Twice a day you go out. And so tell us that protocol, please, Chris.
Yeah, twice a day we inflate our weather balloons. They're about 5 feet across, about 6 feet or so tall, so not nearly as big as a hot air balloon, but we fill them with hydrogen, and off they go. We tie, but it's just the balloon is just the vehicle for us. There's an instrument package that we hang from the bottom of the balloon called a radiosonde, and that's what gives us the data. And we're getting data from that thing every second for 2 hours until the balloon pops at about 20 miles above the ground.
That's when it'll break.
Yep, right around a little over 100,000 feet.
Now, is there a parachute to drop that equipment down?
Absolutely. Yeah, we got a little orange parachute that opens up when the balloon pops, and the instrument package hanging on a long string below it just kind of floats back down to the ground, and if somebody finds it, they send it back to us and we use them again.
I'm glad you clarified that, because I thought, oh my goodness, what happens to that thing? Have you ever
piece
not?
of equipment.
Yeah, I'm
Yeah.
sure.
Yeah, that little instrument package is about
And that
$250.
reads-
Yeah.
Yeah. Oh, I'm sure.
That reads what to send back to you to the weather station?
That gives us temperature, humidity levels. It gives us air pressure, which as you go up, the air pressure gets much lower.
Sure.
We're not quite making it out to space. I mean, to put it in perspective, if you've ever been on a commercial airliner flying, they usually cruise at about 35,000 feet, somewhere around there. These balloons are going up about 3 times higher than that.
Oh my.
So way high up into the outer reaches, into the stratosphere, literally. And up. The reason they go up that high is because we want to get this full kind of 3-dimensional picture of all the temperature structure and the humidity and all, because that tells us a lot about the ozone layer and things that are going on way high up in the atmosphere.
What's the temperature range and humidity range from here in the flatlands to as high as you go?
Oh, it is huge. When we have let's say we have a 90-degree day here in the middle of summer, we'll be 90 here, the humidity quite high. We use dew point to tell us what
Yes.
humidity levels. when it's very humid, dew points will be in the 70s. When we're up in the upper reaches of the atmosphere, temperatures are about 60 below zero.
Oofta.
Very cold. So there's 150 degree difference between the ground and 20 miles up. That's a great trivia question. I ask kids that sometimes. How far would you have to travel for it to be, 50 below zero? And, the kids, the North Pole, South Pole, Alaska. And I say, no, just go 20 miles straight up. That's where it's 50 below zero. And the humidity, there's almost no humidity up there. Once you get above, roughly, I want to say about 50,000 feet, in the absence of a thunderstorm, you have almost no humidity. It's so dry. All of our moisture is really low in our atmosphere.
Here.
Yeah.
How come?
Because of the different layers of our atmosphere, it's just the way that our planet developed. With all of our weather occurs in what we call the troposphere. It's the lowest, roughly 40,000 feet, depending on the time of the year. And all the moisture is trapped in there. And it has to do with the air flows over the oceans and the land, the oceans, the air flows going over mountain ranges and the different geography of our planet.
All these things you can't do a darn thing about, can you?
Yeah, I know. And that's why when we talk about, say, winter weather even, we look to the Pacific Ocean and we say, what's it doing at the equator? That's that El Nino, La Nina thing.
Yes.
The ocean temperatures play a huge role in the planet's weather thousands of miles away. So we watch that very carefully.
One of the things we don't watch very carefully here on Viewpoint, I've noticed, is we're not very careful about bringing on our sponsors on the exact minute we should. So I'm going to let Mr. Ash solve that problem right now. And we're right back live in the studios here at WLCN, high on the hill at County Road 2250, a.k.a. Lazy Row. Our guest this morning, Mr. Chris Miller, representing their wonderful weather service we had here just east of town. Chris didn't just learn this by getting a Boy Scout merit badge. There's a great deal, and I'm being somewhat facetious there because I took a semester of meteorology so I wouldn't have to take chemistry.
Good choice.
The only thing I remember about that is the Beaufort scale. I do remember that, but I can't tell you the numbers. There's a great deal of education necessary to be the expert that you are. Let's just kind of go through your when you first started in meteorology. Take us through academic, or were you completed?
Well, my interest started when I was 8 years old.
Was it some special event?
Not even no. It was, actually, I was terrified of tornadoes and storms as a kid.
Where was your home, Chris?
Milwaukee, Wisconsin.
Okay.
Yep, I grew up in
And he got out of there a pretty good guy.
Yeah, I know.
Well, I'm from Wisconsin, too. I was born there.
That's what I heard.
Yeah.
Yeah.
Oofta.
Don't you know? Yeah,
Don't you know? Yeah. Well, you heard all those things.
I have, yeah. But as a child, I was very interested in weather. And, and I talked to a lot of kids or parents even, that say, my 7-year-old, 8-year-old, 10-year-old, they're so crazy about the weather. It starts at a young age. But I was fortunate enough that math and science were just my things. I
dropped into your niche.
Oh, yeah, I could do it very easily. Spelling, forget it. I was just, I'm going to be in any spelling bees, but I'll tell you, math and science were it. And so what I did, this is in the days way before the internet. So, went to the local library and I looked up, what do you need to do to be a meteorologist? And this book I got talked all about, hey, when you're in high school, take, all the math and science you can get. It doesn't have to be meteorology, any science, because meteorology is a mix of, there's a lot of chemistry involved because of the atmosphere and water vapor and other chemicals in our atmosphere. So there's that. There's physics, because you got to know how things move and how they react when they move and things like that. And then the math part, you think, well, what is math? You convert Fahrenheit to Celsius, or what's the big deal? Well, all of our computer simulations are math driven. What we try to do in the simulations is we're trying to model, we call them models, we model the atmosphere using mathematical equations. And it's extremely complex using calculus and other advanced math. So in high school, I took all the math I could get. Literally, I went to summer school 2 years just to get a bunch of math, took all the science I could get. Went to the University of Wisconsin in Milwaukee that had a meteorology program. And at the same time, I knew that in college, you're not going to learn everything you need to know about it. You're going to learn just the basics, and you're going to learn the foundation, really. So what I did was I volunteered for 6 years at a local television station in Milwaukee with the meteorologist there. Again, not every station in Milwaukee. Milwaukee's a good-sized city, you know.
Yeah. It's even bigger than Lincoln.
A little bit, yeah. And Milwaukee didn't have all meteorologists on TV back in the early and mid-'80s. So I hooked up with a meteorologist there, and I'll tell you what, you talk about a mentor. This guy taught me a lot of what I know about forecasting the weather, and applied for jobs all over the country, and ended up, I was fortunate enough to, I was willing to pretty much go anywhere just to get my foot in the door with the National Weather Service, because I knew I wanted to do that. And I was placed in Peoria, Illinois, when we had an office there. And my first inclination was to get a map, because Milwaukee, I was a typical Wisconsin kid, right? I thought Illinois was Chicago. I didn't look,
Yeah, right.
I didn't look south of I-80. I don't know, where's Peoria? I thought it was in southern Illinois somewhere. And I saw where it was, and I thought, okay, that's not too bad. That's right in the middle of the state. I'll go there. So anyway, my goal was to get back to Milwaukee as soon as possible.
Yeah.
Just because I knew the weather there. I love the weather up there because I love snow. I love it's weird, but I like the cold weather. The impacts of Lake Michigan.
I knew he had a chink in his armor somewhere.
I just don't. I can't do hot weather. I just don't.
Oh, and you have to learn to do it down here, don't you?
You know, I'll tell you what now. I've been here 33 years now.
That's amazing. So, as you proceeded, then you continued to go for more formal education.
Well, I'll tell you, I had this thought that, hey, once I got my foot in the door at the Weather Service, all I'm going to do is forecast the weather, and I'm going to get to, I'm going to warn people about storms and all this stuff. And boy, my schooling days are over. That was a big wrong. No, I tell you, we go through every year. We go through dozens and dozens of hours of training. Like I said, I've been doing this for 33 years, and we're learning all kinds of stuff about the atmosphere, even today. So it's constant education. It's continuing education throughout your entire career.
What is it about the flatlands here that draws tornadoes to it?
And that's a big part of it, is because to get the right wind structure around a thunderstorm, to get a tornado to form, you have to have a pretty much smooth flow. If you're going over mountains and hills, and they can still get them out there, but they're quite rare. But around here, when you got that unobstructed wind flow coming over the fields, not a lot of topography to deal with. Some people will say, oh, but we have the bluffs in Peoria along the Illinois River. That topography is really nothing. I mean, it looks, you're standing there and you look down and you go, wow, that's a few hundred feet. Yeah. But a thunderstorm would just laugh at that because they're so much bigger, and that topography does nothing.
How does it form itself up to become a tornado?
That is an amazing question.
We go off the air at 9 o'clock.
Right. No, it won't take that long. I tend to go on about things. I love weather. But I'll tell you what, this is something, Judy, that we as meteorologists and the research community, we had theories about how they develop, but you can't get close enough to a tornado to actually figure it out, to measure, Well, there were some pretty smart researchers, a lot smarter than me, that figured out how to measure these things and how to get closer. And about 2-3 years ago, So this is, I mean, just since 2015 roughly or less, researchers figured out how tornadoes develop. And it's amazing. I mean, we had theories, and some of our theories were wrong about how these things developed. When you talk about a tornado touching down, tornadoes don't touch down. They do not.
That's a whole misnomer.
Yeah, they do not come down from the cloud. We see the funnel, and you see the rotation, the clouds are swirling, and you think, oh my gosh, there could be a tornado. That's one part of it. That's not the only part, because what happens is they develop at the ground first, and they work their way up. They spin up, and they meet.
There's something nobody knew out there.
Yeah, we thought about that for a while. When we train our weather spotters every year, we had started training them on that about 10, 15 years ago, saying we think this is how it happened, but we haven't measured it for sure. We couldn't prove it. There was actually a group of researchers, and I think the main one who proved this, she actually is a professor at a university in Ohio. She proved it. And they develop at the ground, and they work their way up to the rotation in the cloud. And then we went, okay, that makes sense, because why are there times when you see a funnel cloud?
Yeah.
And you say, well, why didn't that one produce a tornado, but one that looked just like it did? What's the difference between these two? We had to figure out that puzzle. Why didn't that one touch down all the way, but the other one did? Well, they're not touching down. That's why, because something was missing at the ground for that to develop. What they found was missing was it's all about temperature. It's all about temperature and humidity. In the storm itself, you've got the area where it's raining very heavily, and you've got hail, and so it's cooler in the area where it's raining, and it's warmer and it's humid close in, and where those are interacting, it starts some, and the wind flow, it starts some rotation that forces its way up. So yeah, it's amazing.
We have a question, all right?
You gotta
put
use
your headset on, Mr. Miller. So
Don't put the coffee cup on your ear.
Go right ahead, caller. 1 minute, just stand by here. Okay, go ahead, caller.
Okay, I was wondering if you could repeat how far the weather balloon has to travel to be below zero.
Oh, okay.
Okay, yeah. Go right ahead. Thank you for that question. Boy, somebody's paying attention.
Very good. Yeah, no, that's an excellent question. For the weather balloon to get temperatures below zero, we're talking now. I had mentioned, it was 50 below where the balloon popped at about 20 miles up. To get below 0 Fahrenheit, we're looking at a level of roughly 20,000 feet or so above the ground. It varies by time of the year. And I'm referring to this time of the year, in summer, early fall. You got to get roughly about 20,000 feet, or about 4 miles above the ground to get below 0 Fahrenheit. Now in winter, not quite as high. It all depends. Those days when we have the cold winter rains and stuff like that, you may only have to go, or maybe a little bit of ice, sleet. You only have to go about 10,000 feet off the ground to get below zero. And then if we have the below zero temperatures, well, it's right at the ground. So it varies with height as the year changes.
Well, if the caller will report to a radio station up here on Lady Row, we'll give her a certificate for lucid questioning.
Yeah.
Very, very, very good question.
Yeah, that's an awesome question.
Once again, Judith, you and I, we get engrossed with our guest, and we forget to announce 648-5510. We have a guest this morning, just a cornucopia of knowledge, Chris Miller of our weather station. Besides that, he's a whale of a nice man. So feel free to call. He'll be nice to you, even if you ask a dumb question.
Look how he treats me. He's
as my daddy used to say when I was struggling in school, Bill, there are no dumb questions.
Yeah.
If you feel a need for it, you ask it. So, Chris, you have alluded to the fact when we've had you before that this area, generally in the Midwest, is kind of known as Tornado Alley. Mm-hmm. Is that's still true today?
Yes. Yeah. In fact, we'd been speculating about that. We've been kind of waving that banner, and we don't want that title.
No,
you don't
thank
want to
you.
be in Tornado Alley.
Yeah.
We think of, Oklahoma, Kansas, and Nebraska, those areas. But having spent 33 years here looking at the weather, studying the weather, and I look at tornado numbers very closely and analyze those, I've just seen so many increases in the last several years. And I thought, come on, this has got to be, we have quite a few tornadoes here in central Illinois and other parts of the state as well. It almost runs right up the I-55 corridor, in which we are in, because they get a lot of them down around St. Louis. We get several here and north here toward Bloomington and even toward Peoria. And they get their fair share around the Chicago area. That windstorm, that derecho we had about 3 weeks ago, they had 15 tornadoes out of that between Rockford and Chicago. So fortunately, most of them were smaller and weak. But anyway, a researcher at Northern Illinois University actually looked into this and said, okay, I'm going to redo the map of Tornado Alley because, we're tired of seeing this strip from Texas to Nebraska. He did that, and what he realized is Tornado Alley has actually shifted a little bit.
Because why?
Out of the plains. A lot of that has to do with the warming waters in the Gulf of Mexico. A lot of it has to do with more available moisture for these storms, because that's what they feed off of, and they need the moisture and the moisture difference in that storm and the temperature difference within storms. And he noticed that Tornado Alley was shifting more toward the Mississippi River Valley. And they still get a lot of them out in the plains, don't get me wrong. They get a lot of tornadoes in Oklahoma and Nebraska and whatnot. But it's almost as if there's a branch, almost think of a tree with a branch that comes off from about Arkansas up toward the Boot Heel of Missouri, right up into Illinois and even parts of Indiana. That have seen a lot of tornadoes in the last 30 years.
I don't think any little kid likes storms. There's generally a fear. You don't necessarily jump under your bed and whimper, but we get frightened. But I don't remember there being a lot of tornadoes when I was growing up in the Minneapolis area. Mm-hmm. What are they missing that they avoid them? And Milwaukee probably didn't get as many as a lot either. No,
we didn't. You look at the numbers, state of Illinois, we average around 55 tornadoes every year. Wisconsin, they might average about just under 30. Uh-huh. And I think it's 24, 25 around in Minnesota. We're seeing that change also. It's starting to increase more and more. They had a terrible tornado season up in Minnesota this year. Up into northwest Wisconsin, particularly when we got late June and through July. Things are starting to focus up there. I don't want to pull out the climate change card and say that because we don't know yet for sure if that's causing the increase. What we have noticed, there have been some studies done on this, and they've noticed that we're increasing our number of weak tornadoes. The ones, they can still do damage, but they're on the ground for a very short period of time. Sometimes as little as 10, 15 seconds, all the way to, maybe 2, 3, 4 minutes, something like that, a few minutes. We're seeing increases in those. We think the reason we're seeing the increases in those are better reporting.
Oh.
In other words, they've always occurred. Mm-hmm. Just that if something touched down for 30 seconds back in 1965, if it didn't do any damage, they'll talk about it locally, but it's not going to get reported to anybody. It's not going to be on the news. And not too many people were running around with cameras over their shoulders to take pictures of it back then. Now everybody has a camera in their pocket, in their purse, on their cell phone. Mm-hmm. And so these weak tornadoes, we're getting reports of them left and right, all over the country.
Is that the good news or the bad news?
I guess it's just the news. Yeah, because, like I said, they've always been happening. It's just that they're reported better. Now, from the Weather Service point of view, we're very we're very proud of what we do, and we never. I mean, contrary to what people believe, we don't want to go to work and get paid to be wrong, right?
Yeah.
But I'll tell you what, we want to get a warning out before that storm hits, and if something pops up suddenly and we don't have a warning out, that's tough. That we take that hard and we look into that.
Chris, we have a question. All right, here's your headset, Mrs. Busby. Go right ahead, caller.
Chris, the derecho that hit Iowa and northern Illinois, what's the difference as far as the storm between that and the tornadoes?
Well, the difference.
Thank you, sir.
Thank you. Yeah, that's another great question, because derechos we don't.
We got smart listeners, Chris.
We do. You guys got some great listeners. The difference between with a derecho and a tornado. Derechos, think of a large line of storms that's going to sweep through an area and affect a very large geographic area. In fact, there's a very technical definition of what a derecho is. I'm not going to get into that. It's a line of storms, intense squall line. I think most people have probably heard of squall lines. Lines of storms with straight line winds. The difference between those and regular squall lines is the fact that they travel for so far, and they have just the right ingredients to create these high wind gusts for a long period of time. Mm-hmm. Typically, a line of storms will go out, give you some wind, and the wind dies down after a few minutes. Derechos, the wind will go on and on and on. Now, a tornado, as the caller asked, a tornado is a much smaller feature. Usually, the average tornado in Illinois is about 100 to 200 yards wide, so about a football field to two wide. They can be much wider. I've seen them, half mile or more wide. Those are the bad ones. The wider they are, usually the worse they are. Not always, but typically. But at any rate, they're much smaller within an individual thunderstorm. So think of a tornado as coming from one thunderstorm, where a derecho is comprised of a line of multiple storms, all kind of getting their act together. They're all kind of helping each other out produce all this wind, so to speak. So
Unionize.
Yeah, they're putting their forces together.
Yes.
For such good things.
Hurricanes that hit the Gulf Coast, even into Alabama and Mississippi and so forth. Residuals from those.
Oh, yeah.
Up in the Midwest and sometimes way up into the Northeast. Does that depend upon the strength with which they hit our coast?
Yes. Depends on the strength at which they make landfall. It depends on the what's going on in the weather in the Midwest at the time. So, for example, if there's a front coming through, colder air clashing up against that warmer air, the hurricane will ride right up that front. It kind of uses that front almost like a conveyor belt, and will come right up into the Midwest. Typically, when there's a hurricane on the East Coast or in the Gulf, our weather here is very quiet. We're under usually high pressure, which is why the hurricane's there in the first place, is because of the high pressure over us. It helps the hurricane get stronger, actually. And we're usually sunshine and, nice temperatures. But they can curve up this way, and they have copious amounts of rainfall. And that's something we got to watch out for. We had one in June, very early in the season. We had remnants of hurricane, I think it was Cristobal, came up here on June 9th of this year, very early in the season. But typically we don't see these until August and September. So we're just getting to the peak of hurricane season. There's already, I think, been 16 named storms in the Gulf and the Atlantic already in the season. And
so how does that bode for the summer then?
For our weather, or
yeah,
because the one thing we need to watch out for, what that could bode for us, is extremely heavy rainfall in some areas. And I'm talking about not just a thunderstorm dumping an inch or two of rain. I'm talking about, several inches of rain.
Here we've been praying for rain. We're going to get it, huh?
Well, we watched the Gulf very closely. We were watching that Hurricane Laura to see if it was going to kind of come up this way. And it came up. It made a curve, and it affected southern Illinois. Our friends down around the Ohio River Valley, they got 2 to 4 inches of rain down there. We couldn't buy a raindrop here.
Yeah.
We could have used some. And droughts, when we break droughts, like we did in 2012, we had that terrible drought then. The only thing to break that drought was the remnants of a hurricane. And it happened in mid-September.
Is that right?
Yeah.
You know, I mentioned the hurricanes. I always thought these pilots who flew into the eyes of the hurricane out in the Caribbean were special men.
Yes.
And I presume that's so. Would you think I'm correct in saying that?
You are absolutely correct. Yeah, we call them hurricane hunters, and they fly special aircraft outfitted with instruments.
I can just see a wing coming off there real easily, you know.
I'm telling you, those guys and gals are the best.
Is that
pilots.
why it says on their door, the timid need not apply?
Yeah, exactly. Yeah, I mean, you got to have some gumption.
Oh my!
Because it's a bumpy ride, and you got to be one of the best pilots in the world to get your. It's bad enough flying near a thunderstorm or around a thunderstorm with the turbulence. If you ever been on an airline with turbulence, imagine trying to get into a cluster of thunderstorms all rotating around, what a hurricane is. So, no, those guys and gals do an amazing job, and we couldn't forecast what we do with hurricanes if it wasn't for their dedication. I'll tell you that much.
Wow.
Yeah.
Let's go back to the economics of this station out here. We have how many employees?
We have currently 21. We're going to bring.
That's amazing.
Yeah, we're going to have 2 more on board here pretty soon. And
you mentioned that you had a high number of applicants, which is kind of interesting.
Yes, a lot of people interested. A lot of young kids coming to want to come to this station to work to start their careers. We've our staff there. I don't want to say we're old and crusty, but we've had a lot of the same people at our office for the last 20-25 years, and we're getting to that point
that's
now.
Stability for sure.
Yeah.
Exactly. We've got a lot of experience here on our staff, and we're bringing in a new crop of some great young people, and we're going to work with them closely and build them up, and they'll be the next generation.
When you have your coffee break, do most of them admit to having been afraid of storms, in awe of storms, as an 8-year-old like you were?
Yeah, I tell you, a lot of my coworkers had experiences as children, either a major interest for whatever reason, or a lot of it was related to a major, a tornado, a thunderstorm, or a big winter storm that really piqued their interest. So yeah, that has impacted many of us at the weather station. Yeah.
Our guest this morning, Chris Miller, Major Domo of the weather station out on the east side of town, just underneath that big golf ball out there by the Oakland County Airport across from Lincoln Christian University. Chris, we appreciate your taking your time.
Oh,
You're
bless
always
you.
very gracious with your time, and I know it's limited. So thanks to Chris Miller, and we'll close with one I always like to come up with. Be the reason somebody smiles today. Thank you.
That's
for
right.
Viewpoint.
You're welcome.